The voyage of spacecraft are some of the most iconic and remarkable achievements in the history of space exploration. When NASA first launched Voyager 1 and Voyager 2 in 1977, the missions were meant to last a mere 4 years. Their goal was to explore the outer planets of our solar system: Jupiter, Saturn, Uranus, and Neptune. What was once thought to be a simple planetary flyby has turned into an astonishingly successful ongoing mission that has lasted more than 45 years. The fact that the spacecraft are both still operational after so many decades and remain the most distant human-made objects in space is a remarkable achievement in itself. Voyager 1, in particular, is the farthest human-made object from Earth, currently traveling through the vastness of interstellar space. This is a feat no one could have predicted in 1977. The voyage of spacecraft have continued to redefine what it means to explore the unknown and extend the frontier of scientific knowledge in ways that were previously unimaginable. The length and success of the mission are a testament to the ingenuity and foresight of the scientists, engineers, and visionaries at NASA who designed it. The journey of the voyage of spacecraft started with a groundbreaking discovery by Gary Flandreau, a scientist at NASA's Jet Propulsion Laboratory, JPL, in the 1960s. While conducting trajectory analysis for NASA, Flandreau stumbled upon an astonishing alignment of the outer planets that would occur in the late 1970s. This rare alignment, where Jupiter, Saturn, Uranus, and Neptune would all fall into a unique configuration, was the key to making a fast, energy-efficient voyage to the outer solar system. Flandreau realized that this alignment offered a once-in-a-lifetime opportunity for a spacecraft to use gravitational assist from each planet to accelerate and change its trajectory, allowing it to reach distant destinations in the solar system much faster than previously thought possible. His discovery led to the creation of a plan that would allow NASA to send a spacecraft to each of the outer planets, dramatically cutting down the time it would take to explore them. By using the gravitational pull of these planets, a spacecraft could gain speed like a stone being flung by a slingshot. This amazing insight reduced the travel time from Earth to Neptune, a typical trip that would take 30 years, to just 12 years. However, the alignment was extremely rare, occurring only once every 176 years. This made it the perfect moment for NASA to seize the opportunity and launch a mission. Flandreau's calculations, made with basic tools like pencils, paper, and a slide rule, were instrumental in setting the stage for one of humanity's most extraordinary space missions. In the summer of 1977, NASA launched two identical spacecraft, Voyager 1 and Voyager 2, just 16 days apart to take advantage of this rare planetary alignment. While the mission was initially designed to last just 4 years, exploring Jupiter and Saturn, it soon became clear that these spacecraft were capable of achieving much more. The initial goals were straightforward: fly by the giant planets of Jupiter and Saturn, take close-up images of their moons, and study their magnetic fields, atmospheres, and other characteristics. However, the data they collected during their planetary encounters exceeded all expectations and opened new doors for science. The spacecraft revealed surprising and unexpected details about these distant worlds, including Jupiter's raging Great Red Spot, the presence of volcanic activity on Io, a moon of Jupiter, and the discovery of Saturn's magnificent rings with their intricate structure and complex dynamics. These groundbreaking discoveries forced scientists to revise their understanding of how planets and moons form and behave. Even more remarkable, Voyager 2 went on to explore Uranus and Neptune, worlds that had never been visited before, giving humanity its first and only close-up views of these enigmatic planets. The Voyager missions were not only technological marvels, but also triumphs of engineering. Designed with the most sophisticated tools of the time, these spacecraft were outfitted with 10 scientific instruments to study planetary atmospheres, magnetic fields, radiation, and more. Remarkably, these instruments operated on technology that would now be considered obsolete by today's standards. The onboard computers, for instance, had just 69 kilobytes of memory, far less than the memory in even the simplest smartphone today. Yet these machines functioned autonomously, managing complex scientific operations, navigating through the asteroid belt, and transmitting data back to Earth. This was done with a transmitter that used a mere 23 watts of power, less than the power used by an ordinary light bulb. Voyager's communication system had to beam signals across billions of miles, traveling through the vast emptiness of space. The spacecraft's high-gain antenna, a 12-foot wide dish, was key to enabling these long-distance transmissions. Even with these limited resources, the spacecraft collected and transmitted an incredible wealth of data. This achievement exemplifies human ingenuity and efficient engineering, pushing the boundaries of what was once thought possible despite technological constraints. The Voyager spacecraft were designed to be resilient, navigating the harsh environments of deep space and sending back valuable data. Voyager 1's journey was especially challenging as it crossed through the asteroid belt on its way to Jupiter, a task that had previously been attempted by earlier spacecraft, such as Pioneer 10 and 11. The true scale of the achievement becomes apparent when considering that Voyager 1 was the first spacecraft to leave the orbit of the solar system's largest planet, Jupiter, and venture beyond the known confines of the solar system. Similarly, Voyager 2's journey to the outermost planets, Uranus and Neptune, was groundbreaking. In 1986, Voyager 2 made history by becoming the first spacecraft to fly by Uranus, providing detailed data on the planet's unique characteristics, such as its magnetic field tilted at an odd angle and its faint rings. 3 years later, it made another incredible achievement, becoming the only spacecraft to date to visit Neptune, revealing a dynamic world with supersonic winds and a mysterious dark spot akin to Jupiter's Great Red Spot. These discoveries expanded our understanding of the outer planets and proved that even in the cold, distant reaches of the solar system, unexpected complexities awaited exploration. The Voyager spacecraft have now entered the realm of interstellar space, far beyond the influence of the Sun's magnetic field. This phase of their mission began when they crossed the heliopause, the boundary marking the end of the Sun's influence and the beginning of interstellar space. In 2012, Voyager 1 became the first human-made object to enter interstellar space, closely followed by Voyager 2 in 2018. This milestone of immense significance means these spacecraft have traveled far beyond the solar system into the unknown vastness of the interstellar medium, now exploring a new frontier far from the protective influence of the Sun's solar wind and magnetic field. Their data provides scientists with valuable insights into this mysterious realm. The immense challenges of communicating across such vast distances highlight the mission's achievement. Signals from Voyager 2, for instance, take more than 18 hours to reach Earth. Despite these obstacles, the Voyager spacecraft continue to send back data, defying all expectations. Their ability to function and operate autonomously, even as they drift into the interstellar void, is a remarkable testament to the durability of their design. The journey of the Voyager spacecraft is not only a scientific endeavor, but also a philosophical and cultural one. Each spacecraft carries a golden record, a time capsule designed to communicate the story of humanity to any intelligent beings that might encounter it in the distant future. The golden record contains sounds and images representing the diversity of life on Earth, including greetings in 55 languages, a variety of musical selections, and photographs depicting our planet, people, and cultures. The inclusion of the golden record was not only a scientific decision, but a deeply symbolic one, embodying the hope that one day, in the distant future, the spacecraft might serve as a bridge between humanity and extraterrestrial civilizations. Curated by a team led by renowned scientist Carl Sagan, the golden record represents our channel, Digital Discovery's desire to reach beyond our world, communicate with the stars, and leave a legacy that extends beyond our time. As the Voyager spacecraft continue their journey through interstellar space, their legacy inspires awe and wonder. They are not just scientific instruments. They are symbols of humanity's quest for knowledge, understanding, and exploration. Their journey serves as a reminder that the universe is vast and filled with mysteries waiting to be explored.